Please welcome Samuel Pereira and Unraveling the Enigma of Supervision Trees. The stage is yours.
Hello, everybody. Thanks for being here. I'll try my best to give a good presentation in the time frame, but sometimes I get a little bit nervous. So if I start speaking too fast, please let me know and I will slow it down. But can you see the screen that I'm sharing? Okay, awesome. So like Michael said, today the talk's going to be about supervision trees. And let's start. I was going to give an introduction, but he gave a red, so awesome. And before we start talking about supervision trees, I think it's very important that we talk about what makes an Elixir application robust and resilient. So the first topic that I would like to mention is the OTP framework. And OTP stands for Open Telecom Platform. Although nowadays it's not much about telecom anymore, it's more about how we build software that has the property of telecom applications. And the OTP framework is a set of libraries and design principles like behaviors, gene servers, supervisors, and those design principles and libraries will help us make reliable, scalable, and fault-tolerant systems. And in Elixir, everything runs inside a process. Those processes are extremely lightweight. You can have 100,000 and millions of them running at the same time in your application. And by default, those processes, they don't communicate with each other. So if one of them fails, it will not affect the other process. The other ones will continue with their lives. Because in some object-oriented languages that have lots of sequential coding, sometimes a single process that fails, it will crash the whole system. So in Elixir, we don't like to do defensive programming. That it's like when we try to handle every bad situation possible that can happen. And we don't do that because there's like several things that can happen, like a bug, a memory that's corrupted, a network failure. And if we started worrying about every scenario possible, we'll spend more time doing that than creating our software. So we let it crash and we fail fast. And like there's an example when we have like a printer or some other electronic device that's not working properly, we can lots of times we just restart it and it will go back to its initial state when it was working and will start working again. So in Elixir, we do the same thing. We focus on how to recover from failures and restart it from a clean state. And here it's where the supervisors and the supervision trees comes. Supervisor is also a process, but it's a process that's responsible for supervising and managing the whole life cycle of other processes, like how they will start up, how they will shut down, and if something happens, be it expected or unexpected, how we will restart those processes. And this is crucial for making resilient applications. Okay, so what are supervision trees? They are a very important concept in the OTP framework, and it's designed to handle failures gracefully and make sure that our applications will not blow the whole everything if something bad happens. I made a little draw here of a very simple supervision tree, and it's just to show that supervision trees, they are a hierarchical structure, and in this structure, each node is a process. And those processes, they are organized into a tree-like topology of workers and supervisors. Workers are the processes that they are the ones that do the computations. They are the ones that perform the actual workers. And then there are the supervisors, which are also process, but they are responsible for managing the life cycle of their children process. So this hierarchical structure, it will handle all the starting, terminating, and restarting of all the process according to our instructions. Because that way we can start off with a clean state, and most of the time that's enough to solve our problems. But one thing that I'd like to point it out that I have seen it happening before, it's that there is a default tolerance of errors, and the default tolerance, it's 3 restarts in each 5 seconds. So if your application is going above that threshold, it's going to crash it. And when here in this node, like when, let's say like the supervisor here in the left, when it crashes, it will be responsible for all the children process that are beneath it. And also each supervisor here in the supervision tree, it can have its own supervision strategies and its options that don't need to be the same of the root supervisor. And this is essential for us to have a self-healing application and a fault-tolerant application. Oh, here I just I picked from the internet a picture that's just to show how supervisor workers, like we define the supervisor, it will start its children processes, it will monitor them, and if they crashes, it will handle those crashes according to our restarted strategies. Okay, and how can we build a supervision tree? So there are 2 ways that we can start a supervisor. The first one, it's by simply calling the start link function in the supervisor module. And we will pass all the children process that will be supervised and its options. And the other way to create a supervisor, it's like the picture that I did here. That's a module-based supervisor. And the difference between those 2 ways of creating a supervisor is that the module-based supervisor will give us more control on how all the children process are initialized. Because when we call the start link function directly with a listing of children's, they will all be automatically initialized. But here, when we have a module, they will be manually initialized inside the init callback. And a general guideline is that we will, like most of the time, we need to use the module-based version of the supervisor. I think the only time that's recommended for us to use the first option it's on top of the supervisor module and in the application callback, the application behavior, sorry. So here, how do we configure our supervisor? We use the supervisor behavior, and by definition, we have the start link function that will start the supervisor, and it's advised to give it the name because a process will have its PID, that it's identification, but when a process dies and it's restarted, it will have another PID. So if another process wants to call it, it will be very hard. And if you give a name for it, we can always call it by name. Even if we have like applications in different nodes, we can call a process in another node just with its name. Also, here in the init callback, we have the children list that it will have our process, and all those processes we can define a restarted strategy that we will talk a little bit more in the next slides. But it's very important to know that all those processes, they are the order here matters. They are started from top to bottom, and they are terminated from bottom to top. And why does that matter? Like when we have our application module that will start our whole application, let's say that we have a process that depends on the database to work. So it's very important that you put that process after the database process, because if you don't do that, when it starts, the database will not be started. And the same thing is important for like workers that depend on the endpoint module of Phoenix and like Oban jobs and stuff like that. Because here in I have worked in a place that they didn't pay attention for the order here. So when it had like a graceful shutdown, and the endpoint was the first thing that was going to be terminated. So the application was still like receiving requests, but it was not able to handle it because the endpoint process was already terminated. So it's very important that we take care of the order here. And, oops, sorry. Here you can see that every process, it has an option that's very important, that it's the restart option. By default, they all have this permanent option. And what this means? It means that the child process will always be restarted when it terminates. And then we also have the temporary option, and that means that regardless of the supervision that you defined for your supervision for your supervisor, this process will never be restarted. And the last option that we can use is a transient. And these options, the process will only be restarted if it terminates with a reason that it's not normal, it's not shut down, or it's not the shutdown term tuple. So it's very important that we pay attention and we check which option is better suited for our process. And we also can define a strategy for our supervisor. And here we have the option of 4 options to 4 restarted options for our supervisor. The one that I see that's used the most, it's the 141. And here, if a child process is terminated, only that child process will be restarted. And this option is good when the process, they are independent from each other. And in that case, there is no reason for you to restart the other process just because one failed. We also have this one for all option. And in this option, when a child process is terminated, all other processes are also terminated and restarted. I was watching a talk the other day about Broadway, which is like a library for those of you who don't know, a library in Elixir that we use to communicate with Kafka, SQS. And they have their processors process, and those processors are implemented for the people who use their library. So because they don't have control of it, the strategy that they use for those processors are the one for all. If one process uh, dies, all the other processes will be also terminated and restarted. The other option that we have, it's rest for one. And in this option, when a process is terminated, only the process that started after that one in the supervision tree, they will be terminated and restarted. And that's a good option for when you have process that they only depend of those processes. And the last option that we have, it's the simple one for one that's we use for dynamic supervisors. Okay, we have a special form of supervisors in Elixir, and those are the dynamic supervisors. And they are designed to manage a set of dynamically created worker processes. Because the other supervisors, we have like a predefined list of process that we want to start it. But in the dynamic supervisors, we have the flexibility to start them on demand. So if we have workers that they will have like workloads that will have like lots of variabilities over the time, we can create, we can stop, and then on demand. So this is very important in lots of situations. And also another thing that I thought it would be very nice to bring, it's good practices when we are using supervisors. Okay, when we create a supervision tree, it's very important that we pick the best supervision strategy for our supervisors, because like we saw there's like one for one, rest for one for all. And in the supervision tree, each node, like each supervisor below the root supervisor, it will have its own children processes, and it can have like a different supervision strategy. So it's very important that we see our use cases and that we check which option is the best for us. It's not very good to always go with the default option, you know. Also, it's very important that we correctly structure the supervision tree, because we need, if we do it that way, when we want to maintain our applications, when we want to see where the bottlenecks of our applications, it's a lot easier. Also, if we don't have like a good structure for our supervision trees, a process that's not behaving correctly can affect process that it should not affect. So it's very important that we pick the best strategies for the supervision tree, and also that we have a good structure for it. And our supervisors, it's also good that we keep it to a minimum, like we don't introduce lots of codes to it, business logic. and stuff like that. It's important that the responsibility of our supervisors is to supervise other processes. And also for supervisors that will have like a large number of child processes, it's always important that we think if dynamic supervisor it's not best suited for that option. And last but not least, we have lots of tools like the observers, lots of telemetry tools in Elixir and Erlang to manage, to oversee our supervisors, like when they are crashing, why they are crashing, how often they are crashing, uh, how much load they are taking, like how many messages they are being able to process. So it's very important that we log that, we monitor that, that we can see what's affecting our applications, what we need to change. So this is very important. And I think that's it. Thanks everybody for watching it. I'm sorry if it was too much theory, but I believe I covered most of the stuff in the supervision trees.
Much for your presentation. As Mauricio said in the chat, it's been an amazing explanation of the topic, and we are glad um, to have the opportunity to hear from you about this. So now let's move on to the Q&A section, in which you guys are gonna be able to ask Samuel questions in the chat window. In the Q&A in the Q&A section, and get answers from Samuel. So now it's time for you guys to ask questions.
I know like it was lots of theories. I think it's very nice like to read the documentation, to create an application and to make it crash on purpose, to see what happens, to use different supervision strategies to see how your application will behave. It's nice like also uh, to make like a supervision trees with all the nodes and see what happens like if a node like on the bottom of the supervision trees crashes. So I think when you try to practice a little bit, everything will definitely be a lot more clear.
So the first question comes from Chris, who says he doesn't have experience yet with supervisors, and can you give us some examples of real life usage? When should we use them, etc.? So I think this was partly covered next to Samuel talking about specific types of supervisors, but I think I'm curious if you could elaborate on that.
Yes. So, like in production, I believe every Elixir application, when you create like a new application with mix new, and it will create the application module, and if you have like a database in your application, if you have HTTP endpoints and all of that stuff, they even if you don't see it, sometimes you start working with Elixir and you are able to do lots of stuff, and you never have to use yourself like a supervision tree, but in every application that you work, it will have a supervision tree. And if in your applications you open the module application.ex, That's a supervision tree, and there you can see the list of all the process that you have there. But like a real example that we have, it's the Broadway library that was created. It's an open source library that was created by the company of José Valim, that's the creator of Elixir, and that's like they took like real care of the supervision tree of Broadway to work as expected, to be able to handle all the messages correctly. So I don't think I will be able to go into the details now, but you can watch their like presentation. I think it's on YouTube, and you, you see it there. But like every application that uses Elixir, it will have a supervision tree. So you definitely will use it all the time. I don't know if I answer it.
Thank you, Samuel, for this answer to the question. So, here comes the opportunity to ask further questions about the presentation.
Chris, I think that when Curiosum uploads this video on YouTube, I will put together like I think I should have put that in the presentation. I'm sorry, like some practical examples, so I just don't talk about theory. But when they put the presentation on YouTube, I will like create real life usage that I think it will be a lot more clear to see, and you can see it there. Okay, I'll do my best to give like a good real life usage that it will make it a lot more clear.
Yeah, this would be greatly appreciated. I think as an addition to this theoretical explanation here, so
Okay, awesome.
that's gonna be welcome.
I'll definitely do that. I don't know, but like between this week and next week, Nick, next week I'll definitely have that.
Yeah, take your time. That's very kind of you to provide this kind of follow up. And we have another question from Jan. You mentioned Oban. How would you address a cyclic dependency where Oban, as an example of a node on the supervision tree, is to receive requests from the app as another node in the supervision tree, as well as trigger commands in the app. So the app supposedly
Okay.
represents a node in the supervision tree, which is in a cyclic dependency with the open worker.
So like not only like Oban, but other libraries that they need a supervision tree. Usually, what they do, they of course in their own library they will create the supervision tree, and in their readme section that they'll tell us to add that supervision tree to our application. But like lots of the times we don't go to see how that works, but libraries usually do that. They'll just create the supervision tree, and in their readme section they will ask us to add that to our application. So it's up to us to see in which order and which strategy that we use for that dependency. Like let's say OBA, for example. OBA, it uses our database like Postgres or whatever you're using. So in your application, you need to put that below the initialization of your database. because this because OBA depends on that.
All right. Thank you for your answer. And we have next question from João Pedro. How can supervision trees prevent cascading failures where a single child process failure triggers a chain reaction within the tree, potentially bringing down the entire application?
Uh, so like if you choose like the one for one supervision strategy for your process, when that process crashes, it will not crash the other process. So if that's something that can happen, you can just you isolate that process, use the one for one supervision strategy that when it goes down, it will not bring down the whole application. That's like the whole point of the our supervisors. It's to like isolate our process and our failures so it doesn't affect the whole system, you know. And like I said in like the good practice sections, it's good that we like monitor our application and that we have logs and everything. And if there's like a process that for some reason, even after restarting, it's still like having a bad state, uh, we need to see why is that happening and correct that. But if you have like a one for one supervision strategy, that will not happen. And also, that's one thing that I like in Elixir. It's that we don't use like lots of try catches that other languages use, but because if we do that, lots of times we can keep like a corrupted state, and we'll never restart our process. You know.
Yeah, that's true. And thank you for this answer to the question. Um, so let's move on to next questions from you guys. We still have some time to hear from you.
But João, before someone like asks another question, just to complement, uh, in the supervision strategies, there's like lots of like strategies, and there is only like two possible ways that a process failing which will crash the whole system. And one option is that if you use the one for all strategy, that's when one process dies, it crashes the whole application. So you should not use that unless it's very necessary. And the other option, it's like if it's crashing and restarting above like the limit, you know, like I think it's five times in 3 times in 5 seconds, something like that. And
All
someone
right.
asked to explain libcluster. I'm not very like well versed with libcluster, so I'm sorry about that.
Yeah, I think Leap Cluster is one of the topics that we would like to have covered from time to time in the meetups. So perhaps this is an idea for a future talk. Basically, we are obviously interested um, in speakers for the next editions of the meetup. So if someone is eager to present the topic of Leap Cluster, then it's definitely in the circle of interest for us. Right. So is there anyone else who wants to ask Samuel questions in the Q&A? So if there are no further questions, Then I think it's over. So thank you very much, Samuel, for your contribution today. I think something's not fully right with my connection, so I'm gonna turn my camera off.
I'll
Um,
turn.
Thank you very much, Samuel, for your contribution and for your awesome speech today. And I think this was a very interesting introduction to the topic of supervisors. And we obviously would like to hear more from you, Samuel, about this topic. And if you do actually do the follow up that you mentioned, then it's gonna be very, very welcome. Great. So I'm gonna give you the links to our LinkedIn and Discord groups right now, so that you can stay connected with us after the meetup. So those links land straight into the chat right now. All right, so coming back to the presentation we had just at the beginning, so that we can announce the next meetup. Let me just show it up again. In the upcoming meetup, we are going to listen to Nitesh Mishra, a software developer and Elixir enthusiast with experience in the information services industry, the presentation on unlocking the power of Absinthe, which is Elixir's library that we use to expose GraphQL APIs. So this is an interesting topic we haven't covered in a while in the meetups, and I think we are eagerly looking forward to hearing from Nitesh about the Absinthe topic. So that's going to be about meetup 27. And in meetup number 26, that's it. So after, so thank you. So obviously, thank you very much to everyone who joined us today. Thank you to Samuel for delivering the presentation, and thank you to all of you, the guests we had today.